Hi guys, and welcome back to Aisha's Academy. And today I'll be going through another assessment and material for Edexcel GCSE, and it will be higher content. And this time we're going to be going through numbers and ratios. I have the video link for the algebra ones that I just posted yesterday in the link above in case you would want to watch that. So let's go. Okay, so question one says find the highest common factor of 72 and 90. I do have a video in regards to highest common factor, lowest common multiple, and all of that jazz on my channel already if you want to refresh your memory. But in regards to this question, whenever it comes to highest common factor and lowest common multiple, first step is you need to work out the prime factors of each of the numbers. So we're going to work out the prime factors of 72. Again, prime factors, there's multiple ways of working out. So it's whichever one's easiest for you. So I'm going to go with 36 and 2. And whenever I come across the prime factor, I'm going to circle it. And then 36 can be split into 6 and 6. And then that can be split into 3 and 2, 3 and 2, circle them. And then 90, I'm going to do 40, 5 and 2, then 5 and 9, then 3 and 3. Okay, so now I've got all the prime factors circled. Next step is to make a Venn diagram. So make a Venn diagram for 72 and 90. So let's look at the numbers that they have in common. So the ones that they have in common, I'm going to circle in red. So they both have a 2. So that would go in the middle. And they both have a 3, which would also go in the middle. So now that I've done that, some people may prefer crossing them out so they don't get confused, so you can cross them out. So then now I can see that for 90, it's just left the 5 and the 3, and for 72, it's left with 3 and 2 2s. Okay, so now I've completed the Venn diagram. Next step, to work out the highest common factor, you multiply the two numbers in the middle together. So yeah, for highest common factors, the numbers in the middle. If the question was lowest common multiple, then you would have multiplied all the numbers together. So 3 times 2 times 2 times 2 times 3 times 5, that times 3. That's for lowest common multiple. But for highest common factor, it's just the ones in the middle. Okay, so in that case, it's just going to be 2 times 3, which would leave us with an answer of 6. So that's literally the answer. Okay, moving on to question 2. It says work out the value of, I'm going to write it out bigger so it's clearer on the screen. So it wants to work out this. So in terms to work it out, we're going to basically simplify the numerator. So remember, whenever you multiply indices, you add the powers together. So it's going to end up being 3 to the 7 plus minus 2. And whenever you have a plus and minus together, it's a negative. So that's going to be 3 to the power 7 minus 2, which is 3 to the 5. Then 3 to the 5 divided by 3 to the 3. So again, now when you divide with indices, you take away from the power. So that's the same as saying 3 to the power of 5, take away 3, which is 3 squared. Okay, so having a look at question 3, it's basically giving us ratios of houses to flats, flats to bungalows, number of bungalows, and it wants us to work out the number of houses in the village. So what we're going to do is we're going to write out the ratio of flats to bungalows. Flats to bungalows. I've just abbreviated it for F and B. So it says that there's 50 bungalows. So now to change that ratio to also find out how many flats there would be with 50 bungalows, from 5 to 50 you times by 10. So on the other side you would times by 10. So that means that when there's 50 bungalows, there's 80 flats. So now we know there's 80 flats. If we now use the ratio of houses to flats, which is a 7 to 4 ratio, so H and F for abbreviations, there's 80 flats. So to go from 4 to 80, we would multiply by 20. And so you'd have to multiply by 20 on the other side. And that would leave you with an answer of 140 to 80, which means that there are 140 houses when there are 50 bungalows. Okay, so moving on to question 4, it says that there's £2,100 of bonus money and it's shared between 10 people, but not equally. So 40% of it is shared between 3 managers and the rest is shared between 7 salesmen. So one salesman is now saying, if the bonus was shared equally between all 10 people, I would get 25% more money. Well, salesman, we need to check if you're correct. So first of all, we need to work out initially what each salesman gets before we check whether Mr. Salesman is right. So we need to work out 40% of 2,100. So 40% of, and there's two ways of working this out. It all depends on which method is preferable for you. Some people can either do the 2,100 times 0.4 into your calculator, or some people like to do the 2,100 divided by 100 times by 40. To be honest, they're both going to give you the right answer. Again, it's just whichever method is preferably suitable for you. So then if we put that into our calculator, that would leave you with an answer of 840, which means the total that's going to be split over the managers is 840. So now to work out what each of the three managers get, we need to do 840 divided by 3. And in our calculator, that would give us an answer of £280 each. So we know each manager gets 280 each. Whereas the salesman, we need to do 2,100 take away 840 to work out the rest. And so in your calculator, that would give you 1,260. Then because there's 7 salesmen, we need to do that divided by 7. And in your calculator, that would leave you with £180. So we know that each salesman gets £180. Now, we now need to work out how much each person would get if it was split over equally. So if it was split over equally, it would just be 2,100 divided by 10. And in your calculator, that will give you £210. So based on what Mr. Salesman is saying, he would earn £210 rather than the 180 that he's getting. But we need to work out if that increase is a 25% increase. And that's based on the formula of percentage increase, which is your new value take away, so your original value over your original value times by 100. And if you put that all into your calculator, you'd end up with a value of, to three significant figures, 16.7%. So as we can see, yes, his money would have increased, but not by 25%. It only increases by like 16.7%. So the salesman money increases by 16.7%, not 25%. So he is wrong. And that would be your final answer. Okay, so moving on to question 5, we have these four numbers. So again, I'm going to write these out again so they're clearer on the screen because they came out slightly blurry. Okay, so what it wants us to do is basically write the numbers in order of smallest to largest. So what we need to do is with the recurrent ones, I'm going to write them out a bit longer than they actually are. So for instance, we have a look at the first one. It says 0.2 and then it's got the recurrent sign over 4 and 6. So that would initially be written out as 0.24646. So it's only the 46 part that would repeat. Then for this one, it would repeat into 0.246666 and so on. And then this one would repeat to 0.2. So now, because the recurrent signs at the start of the 2 and at the end of the 6, that means that whole 3 numbers are going to be repeated. So it's going to be 246, 246, 246. And then the 0.246 at the end, it doesn't really change. So as we can see now, I'm going to compare the fourth number because we can see that the first 3 numbers are the same in regards to the recurring ones. They all, after the 0 point, they all have 246. So if we have a look at their fourth numbers, we can see that there is now a difference. We can see which ones are bigger, which ones are smaller. So because the one at the end, the 0.246, there's no number at the end, we're going to say that's essentially a 0 because there's nothing there. So we're going to go with that one being the smallest one. Then next in line is going to be this one here because it has a 2 as its fourth number and 2 is smaller than the 6 and the 4. So it's going to be the 0.246 with the recurrings there. And then the next one after that is going to be this one because it has the 4 which is smaller than the 6 on the other one. So it's going to be 0.246. And then last but not least is this one, which is 0.246 recurring. So the key thing when you get ordering numbers and it's recurring numbers, I would say write them out slightly bigger. Obviously, don't keep writing the full number because, to be honest, that's impossible. But write it out so then it's easier for you to compare which ones are smaller and which ones are bigger. Okay, moving on to question 6. So this is definitely from a past paper that is out. The full paper is definitely out because I have seen this question before. Okay, so with this question, you've got a cycle race across America, which is 3,069.25 miles. Juan, his average speed is 15.12 miles per hour. And basically, he wants to do a race across America and he cycles 8 hours a day. The key thing in this question is estimate. So you're not expected to use your calculator with the decimal places. No. You need to estimate. Obviously, you can use your calculator to work this out, but as an estimate, there should be no decimals in your answer. So all the values that we can see in the question, i.e. this one and this one, we need to round them up. So with the 3,069.25, the nicest number to round that to is 3,000. With the 15.12, it's nice to round it up to 15. Better. So now, to work out how many days it takes for Juan to complete the race, what we need to do is we're going to first of all work out how many miles he's going to travel in a day. So if he does 15 miles per hour and he does 8 hours in a day, we're going to do 15 times 8, which is 120. So we know he does 120 miles per day. Then to work out how many days it's going to take him, we're going to do the 3,000 because that's the total total estimate of the length divided by 120. And in your calculator, that should leave you with an answer of 25 days. So we know on average it will take him 25 days. Okay. Now, it says that he trains for a race and the average speed he can cycle increases. It is now at 16.27 miles per hour. So we need to figure out how this is going to affect our answer A. Well, there's two ways you could work this out. You could either try and mathematically work this out, or easiest way to think of it is if someone's going at a faster speed, it's going to take them less time. If you have a car traveling at 80 miles per hour, it's going to get there faster than a car traveling at 30 miles per hour. So if he's going at a faster speed, his answer, well, the estimate of the number of days at this new speed will be lower than the answer A. So this would cause answer. This would cause the number of days. Anything along these lines, by the way, you don't have to write what I'm writing out word for word. This would cause the number of days to reduce. So answer A would be lower at 16.27 mph. Okay. Alright, so moving on to question 7, it says Sean pays £10 for 24 chocolate bars. 24 chocolate bars, he sells them now for 50p each. So we need to work out his percentage profit. So then what we're going to do is 24 times 0.5, because we know that 50p is the same as 0.5 pounds. That is going to give us an answer of £12. So we know that he would make £12. So now to work out his percentage profit, aka percentage change, percentage increase or decrease, just to write it out here again, the formula for percentage change is your new value, take away your old value, over your old value, times by 100. Okay, so it's going to be 12 minus 10 over 10 times 100. Put that into your calculator, you'd end up with an answer of 20%. Okay, so on to question 8, standard form. So we've got this really big number here and it wants us to write in standard form, which again, I do have a video of standard form in the link below in case you want to refresh your memory. So how we do it is standard form, the first number that you have must range between 1 to 9.99. And then that is always multiplied by 10, always. So standard form, you always have times to the 10. And then it's always to the power of a number. which I'm going to call x. So it could be to the power of that number. So the power of that number depends on how many spaces you have after the decimal place. So what do I mean by that? Looking at this number, the best number that we can make that fits within our range is 3.246. Now, another key point here is when you're writing in standard form, do not round it. So sometimes people would round it to just write 3.2. No, write down all the numbers after that, or you will lose the marks. Then put times the 10. Then to work out our power, if we have, so I'm going to write it out again with the point in the middle. Now we have the decimal place there. Because it was initially a big number, you then work out the numbers after the decimal place. And we can see that there's 7 numbers after the decimal place, so it will be to the power of 7. If it was a smaller number, then you would count between the smaller decimal place, sorry, the original decimal place, and the new one that you place, and it would be to a negative power. Because it's a big number to a positive power. Okay, so moving on to part B, it's now given us 4.96 times 10 to the minus 3 to the minus 3. That goes based on what I just said, saying smaller numbers tend to be to a negative power. So this time we're changing it from standard form and we're writing it as its ordinary number. So what I'm going to do is I'm going to write the 4.96. Because I know it's going to be a smaller number, I'm going to just stick the zeros here because I don't know how many zeros I'm going to use. Then, because it's to the minus 3, I need to go back 3 spaces from the decimal place that was in the standard form. So 1, 2, 3. So that means my new decimal place would be here. So then it would end up being 0.00496. So remember, whenever you move the decimal place, you get rid of it in the old place. And that would be your final answer. Okay, so let's move on to part C. So Asma was asked to compare the following numbers. So she was asked to compare 6.212 times 10 to the 8 and 4.73 times 10 to the 9. She's now saying that the 6.2, basically number A, is going to be bigger than number B because 6.212 is bigger than 4.73. But the reason why she's wrong is because notice how number A is to 10 to the power of 8 and B is to 10 to the power of 9. And so because 10 to the power of 9 is bigger than 10 to the power of 8, she is wrong. So the key thing is that when you're comparing the size of a number when it comes to standard form, don't look at the number in front, look at the power of the 10. If it's a higher power, it's a bigger number. Okay, so question 9, multiplying fractions. I do have a video on fractions in the link below. Fractions was actually my first video. So I'm going to write it out again so it's clearer for you. Okay, so first things first, before we multiply anything, we are going to change these mixed numbers into improper fractions. So by doing that, let's look at the 3.5 first. So the technique of doing that is you need to multiply the big number by the denominator. So 3 times 2 would be 6, and then add 1. So 6 plus 1 is 7. So it'll be 7 over 2. The denominator doesn't change. Then for 1 and 3/5, it will be the 1 times the 5, which is 5, plus the 3, which is 8. So it will be 8 over 5. Again, notice how the denominator does not change. Better. So now we've got 7 over 2 times 8 over 5. So then when it comes to multiplying fractions, you multiply the two numerators together. So 7 times 8 is 56. And then 2 times 5, which is 10. And then because it wants it in its simplest form, we need to simplify. So we're going to divide both top and bottom by 2. So that'll be 28 over 5. We can't simplify that any further. And because it wants us to answer it as a mixed number, we need to convert the improper fraction back to a mixed number. So that would be 5 and 3/5. Okay, so having a look at question 10a, it basically says 36 to the power of a half. So rule of thumb, anything to the power of a half means square root. So we're basically going to work out the square root of 36, which is 6. And then again, number B is not number B. Part B is also another rule of thumb because it's 23 to the power of 0. So anything to the power of 0 equals 1. So it's just going to be 1. And then part C, we've got 27 to the power of minus 20 minus 2/3. So first things first, when you've got a question with a negative power, what you need to do is you need to flip it into a fraction. So that would be the same as 1 over 27 to the power of 2 over 3. So then now that we've done that, the next thing that you want to do is we are going to work out this part. So if you've got 27 to the power of 2 over 3, that's the same as saying 27 third of 27, like 27 to the power of a third, times 27, sorry, not times 27, 27 to the third squared. So now that we know that when we saw the square root, it's the same, sorry, when we saw to the power of a half is the same as square root. So then to the power of a third is the same as cube root. We're going to work out the cube root of 27, which is 3. So then it's going to end up being 3 squared, and we know 3 squared is 9. So it's going to end up being 1 over 9. Okay. So then question 11 says that there are 3 dials on a combination lock. Each dial has a set of numbers 1, 3, and 5. So each set of numbers here, that's what it means. Okay, and then it says each dial can be set to one of the numbers. And then it basically says that the 3-digit number 553, which is shown here, is one way that the dials can be set, shown on the diagram. So it wants us to work out the number of different 3-digit numbers that can be set for the combination lock. So let's have a look. Okay, so as we can see, if 553 is an example, that means that it's allowing double-digit combinations as well. So in regards to that, what I'm going to do is I'm going to look at the different numbers and I'm going to experiment with the hundreds. So if we have 1, 1, 2, 1, 1, 3, so I'm gonna 1, 1, 1, 1, 2, 1, 1, 3, 1, 1, 4, 1, 1, 5. You can have 1, 2, 1, 1, 2, 2, 1, 2, 3, 1, 2, 4, 1, 2, 5, 1, 3, 1, 1, 3, 2, 1, 3, 3, 1, 3, 4, 1, 3, 5. You're not going to write down every single one. There's a shortcut coming in a second. I just want to write this out just in case some people don't see the pattern straight away. Okay, so as you can see, for when we're just dealing with the hundreds, out of the hundreds, so we've got, so here we've got a 5, and then along here we've got 5. So you've got 5 times 5, which is 25. So out of all the numbers, possible combinations of the numbers that begin with 100, we've got 25 combinations. So because you've got not only the 100s, 200s, 300s, 400s, 500s, multiply that by 5, put that into your calculator, or you can work it out manually. That'll leave you with an answer of 125. So now we know essentially there are 125 different combinations. Okay, now it says how many of the possible 3-digit combinations have 3 different digits. So again, I'm going to look at the hundreds and estimate. So 3 different digits. So we've got, if I set up them, so we've got this 1, 2, 3, 4. Oh, that's not different. Oh, I've made an error. That is not different. This one, 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 this one. So out of 25, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 out of 25, so then we're just going to do 12 times the 5, and that's 60. So we know out of those combinations, 60 of them have different digits. So, okay. All right. So let's have a look at question 12. So question 12, it's basically given us this number for x. I'm just writing it out again. And it wants us to prove algebraically that x can be written as 24 over 55 for anyone that can't see that clearly. So with these, love these questions. Literally, all you need to do is, right, you want to make two numbers which both have the same decimal places after. So that when you subtract them away from each other, it leaves you with a whole number. What do I mean by that? If I multiply this number by 10, I'll be left with 10x is equal to 4.3636. So now I want to make another number that's quite similar that also ends in 0.3636 recurring. So I'm going to multiply by 100 because that would move back two decimal places. So 1, 2 times 100. So then that would, multiplying the 10x by 100 would leave me with 1000x. So 1000x would be equal to 436.36 recurring. So now if I do 1000x, take away 10x, I'd be left with 990x. And 10x was 0. Oh, it was 0. No, it wasn't. It was 4.3636 recurring. Take them away from each other. The recurring are going to cancel out because they're both very similar. So you just end up doing 436 take away 4, which is 432. So then now to work out what x is, it would be 432 over 990. So then because it wants it to leave it as a fraction of 24 over 55, we just need to do some really good simplifying to end up with that answer. The first thing, I'm going to divide by 3 on the top and the bottom. That would leave me with, if you struggle to do that, you can, if it's a calculator paper, you can use your calculator. If not, then I would recommend doing short division or long division. So then that would leave you with 144 over 330. So then now I'm going to try dividing them by 6. And then that would leave me with what they want, which is 24 over 55. And that's how you answer that kind of proof question. Okay, so moving on to question 13, it says root 3 plus root 12, and it wants us to express it in the form a root 3. So this is all about surds. So root 3, we can't really simplify that any further. Whereas root 12, I did mention this in my surds video. If you ever want to change and simplify a surd, you would need to think of a squared number multiplied by a non-squared number. So I know for 12, you could do root 3 times root 4, because we know 4 is a squared number and 3 is not a squared number. So then the root 3 won't change, but then the root 4 will simplify into 2. And then to write that, multiplying surds is the same as multiplying algebra. So if it's 2 times root 3, it's like you squish them together like in algebra, so it'll be 2 root 3. So now we've got root 3 plus 2 root 3, and then adding the surds together is like adding algebra as well, which would leave you with 3 root 3, which is in the format that they want you to leave it in. Then part B, it wants us to express this fractional surd into root B over over C. So I'm gonna write it out again, just make it clear. So first things first, I want to rationalize the surd inside the bracket. And the term rationalizing a surd, which you may see in an exam paper, Edexcel like to use that term a lot. It basically means that you're going to multiply the top and the bottom by the denominator, aka by the surd. And by doing that, it's going to change the denominator into a whole number. So that would be 1 over root 3 times the top by root 3 times the bottom by root 3. That will leave you with root 3, because anything times 1 is itself. And then root 3 times root 3 gives you root 9. And we know the square root of 9 is 3. AKA a shortcut is whenever you multiply two surds of the same number together, is basically equal to the number within the surd, and the surd basically disappears. Okay, so now we know that, well, now we've got that, that is all going to be to the power of 7. So when it comes to fractions and indices, you're basically going to do the root 3 at the top to the power of 7 and 3 to the power of 7. So root 3 to the power of 7 is the same as saying 3 to the half. 3 to the power of a half and then times a 7. We know a half times 7 is 7 over 2. And we know that 7 over 2 is the same as saying 3 to the power of 3. Sorry, 3. Sorry, yeah, it's the same as saying 3 to the power of 3 times 3 to a half. Because we know that whenever we're times in multiplying indices, we add the powers, and we know 3 add a half is 3 and a half, aka 7 over 2. So that can also be rewritten as 3 to the power of 3 root 3, because we know that to the power of a half is the same as root 3, and that's over 3 to the 7. Then, when it comes to dividing indices, you take away the powers. So your power at the top 3, take away 7, would leave you with to the power of minus 4. So that would be 3 to the power of minus 4 root 3. But we also know that if you've got a negative power, it's fractional, so it's the same as writing it as a fraction. So that would be the same as saying root 3 over 3 to the power of 4. And that would be your final answer, because that is the format that it wants us to leave it in. However, I haven't finished because it wants us to write them as integers. So you need to actually work out what 3 to the power of 4 is as a whole number. And that is 81. So that is where they could trick you out. Okay. So question 14, this has also come up in the past paper before as well. It's basically given us ratios of white shapes, black shapes, and basically wants to work out how many circles there are as a fraction. So with ratios, let's look at the white. Let's work out how many white circles there are first. So it says there's a 3 to 7 ratio of white shapes to black shapes. So that means out of 10, because if you add the two ratios together, you get a total of 10. So it says out of 10, 3 of them are white shapes. And then it says the ratio of number of white circles to white squares is 4 to 5. So add the 4 and 5, that's 9. So I know that out of 9, 4 of the shapes are white circles. So multiply them together, and that's going to give you the total of white circles. So then remember multiplying fractions, you'd end up with 1290. Then we need to do the same for black circles. So then that would be 7 over 10 times, so this time from black circles to black squares is a 2 to 5 ratio. So it's out of 7, 2 of them are black circles. Again, multiply them together, you'd end up with 14 over 70. Now we need to simplify the fractions. So 12 over 90, I divide both top and bottom by 2, or by 3 actually. I'd end up with 4 over 30, and then divide by 2. To end up with 2 over 15, and then 14 over 70 simplifies to a fifth. So then now I've got 2 over 15 plus a fifth, because we need to add those two fractions together to work out the total. So, written that wrong. So again, with adding fractions, you need to make sure you have the same denominator. So I'm going to multiply that whole fraction by 3. So that's going to give me 2 over 15 plus 3 over 15. And then that would be 5 over 15, which simplifies into a third. Okay, so looking at question 15, it says x is proportional to root y. By the way, this is the last question. So x is proportional to root y, and it says y is increased by 44%, and it wants us to work out the percentage increase in x. So in terms of direct proportionality, how to write the formula, I have mentioned this. So you'd say our x, and then is our equal sign, proportional to, and then remember you always have a constant k with direct proportionality, k root y. So that is the equation of the formula, where y is greater than 0. Then it says y is increased by 44%. So, right, if it's increased by 44%, then that's equivalent to 1.44 as a percentage increase. So that's the same as doing 1.44 times y. So then you can rewrite that now as x is equal to k root 1.44y. And now knowing this, we are going to work out what the increase of x is. Well, k is, we don't really know what k is, and to be fair for this one, how they trick people out is we actually don't need to know what k is in this scenario, but usually with direct proportionality you do. So what we're going to do is work out the square root of 1.44 and y. So the thing is with 1.44, it looks familiar, doesn't it? Because if it was written as 144, you would think, square root of 144 is 12. So with 1.44, the square root of 1.44 is 1.2. And if you put that into your calculator, you would get the same answer. So then you'd end up with, I don't know why I still put the square root of it because we just worked out. So times 1.2 and then the root y. We can't really simplify that any further. So another way of rewriting that is 1.2 ky. Now compare this to the first one above. The only difference is because we know that this is equivalent to x. We know that this is equivalent to x. So we can happily say that x has increased by 1.2. And we know 1.2 in regards to a percentage is increased by 100. Well, now it's equal to 120%, which means it's increased by 20%. Now, I hope that last one made sense. Okay, so thank you so much for watching, guys. I hope that was really useful. I will be just throwing in loads of the assessment material this week. My plan is to finish all the Edexcel higher and foundation, hopefully by the end of this week. And yeah, I hope this was useful.